DYNAMOD is a collaboration project between DTU Wind and Energy Systems and TotalEnergies, in which we investigate floating wind turbines in more detail and very specifically to focus a bit more on the dynamic power cable. So the cable that transports the energy from the turbine to some other place where we want to use it. Traditionally, that cable that connects the turbine with the rest of the world is not moving at all. It's just a fixed turbine. So that part is clear. But now suddenly on a floating wind turbine, things are moving around all the time. And that is quite challenging. So we need to make sure we understand how big those motions are, how often it moves, and whether or not the cable will be able to handle those movements. So that's why this is so important to make sure that we do that right. What we did in this project to solve this issue is first we wanted to make sure that our internal tools can actually simulate this in a proper way. So we extended our internal state-of-the-art simulator called HAWK2 such that it can handle these cables in an appropriate manner.
So what we see here is an animation of one of the thousands of simulations we ran in the DYNAMOD project. And we have the power cable here illustrated in red. And if we speed up the simulation a little bit, you'll be able to see these subtle movements of the cable. And it's these movements that add damage to the cable and lowers its lifetime. And therefore it's very important to know exactly how much it moves and how it moves for us to assess the lifetime of such a power cable.
So we have people designing floating substructures, we have other companies designing turbines, control, power cables, so there is a lot of different very big industries coming together here, and all of that needs to be solved in an integrated manner, and I think that is one of the next key challenges.